everybody. In this video, I'm going to go through an activity in the Dictionaries reading. So if I click into here, we see that at the bottom of the page, there are a few optional activities. And I'm just going to do activity 1, where we're going to download a Python file and a text file. We're going to run the Python file, see what it currently does, and then make some changes so that it prints the count of every letter in the text file using a dictionary. So to start off, I'll just save both of these into the same directory on my computer. And I'm just going to go ahead and open the raven.py file in idle so that I can run it and see what's going on and take a look. So it looks like there's a function defined up here called keep letters, and we call it down here on a file name, raven.txt, and the result of that function call is saved as a variable called text, and then we print out that text variable. So let's just go ahead and run this, see what happens. So idle does this thing where if you print a line with a lot of letters, it kind of squeezes it into something and you have to click to expand it. So it looks like we're just printing out this very, very long string. And let's see why or how that is happening. So what does keep letters do? So it opens a file in read-only mode from whatever file name we passed in. So that was raven.txt here. It creates an accumulator variable by making an empty string called modified text, and then it iterates over every line in the file, first setting the line to lowercase, and then looking at each letter in that line if the letter is in this string.ascii lowercase string. So if you remember, this is all of the regular alphabet characters. Maybe let's just go over to the shell and see what that looks like. I'm gonna make it so you can see the bottom here. Alright, so if I import the string module and then I take a look at the ASCII underscore lowercase inside of the string module, what do I get? Just a string that is all the regular alphabet characters. I can see that this is a string if I do something like type a string.ascii lowercase. Yep, and that is a string. And so what is this if statement saying here? If the letter is in this string, so if it's one of the regular alphabet characters, then I'm going to add that letter to our accumulator variable, our modified text. So if letter is a alphabet character, add to modified text. So what's this going to do? Well, it's going to get rid of any punctuation, any spaces, any numbers that were in this text, and just give us back only the letters. And so let's take a look at the actual raven.txt file and see what that looks like. Open it in TextEdit, and as you might have guessed if you're familiar with the Raven poem, this is a poem. We can see that there's some capital letters in here that are getting sent to lowercase by that line.lower method that we call. And you can also see there's punctuation and spaces, and all those are getting taken out by our, I believe, is it modify, by the keep letters function. And what we get back is just the letters, just the lowercase letters from that file. So, what is our task? We want to find the counts of every letter in the text using a dictionary. I'll just copy this into my file just so that I remember what I need to do. So we're already getting back only the letters, so that's a nice first step, right? But what else do we need to do? We need to get those counts. So I'm going to approach this problem by writing a function. Maybe I'll say get letter counts. And what this function is going to do is it's just going to take in that sort of pre-processed modified text, and it's going to return to me a dictionary of counts where the keys will be the letters and the values will be the counts. And so instead of printing this text, I'm going to just print the counts, and then let me write a sort of shell of a function so I can get this working. I call this get letter counts. I call it on some text, maybe I say T. And this is supposed to create a, maybe I'll say return, a dictionary of counts of letters in text T. And so I'll call this dictionary counts. For now, I will just make an empty dictionary, and I'm going to return that. So now I should have a program that runs. It's not getting the counts yet, but that's okay. This is just our first step. And it looks like our program is doing what we want it to because we're printing out that empty dictionary. So now we need to actually create our dictionary. So what is the idea here? Well, the idea is to iterate over every character in our text, and we would like to record that letter. We would like to increment the count for each letter, right? So if I iterate over my text, I'm going to say for character in, maybe I'll even say letter because I know that they're letters. For every letter in my text, I want to increment the count for that letter, right? So for example, if letter was A, I want to say that counts at A, I would like to increment counts at A by 1, right? Maybe that's implied by increment. Okay, so how do I do that? Well, I would like to say counts at A. That's how I get at whatever value counts has for, oh, A is not right. Letter is my variable. Counts at my letter needs to be whatever it was before. Maybe I've already seen 100 of this letter and I need to change it to 101. Oh, yeah. And I do that by adding 1, right? And so that's the basics here. I'm going to run this and see what happens. And we see that we get an error. And what is that error? It's saying I have an error at the line that says get letter when I call get letter counts on text. And specifically inside there, I have an error in the line that says counts at letter equals counts at letter plus 1. So that's this line. And what is the error? The error is saying that the key for the letter O does not exist. And we can see that that's actually the very first letter in my text, right? Is an O. And the issue here is that when I use the bracket indexing operator to try to get at this letter, if it doesn't exist right here, I'm trying to set this key, the value associated to letter, to something. And when Python tries to evaluate this statement right here, it's telling me that there is no key for my letter, which is O, the first time we go through this. And so one way I can solve this is to say, well, if my letter is in counts, so that means if I've already put it in here, then I can do this, right? This means that this key exists, and so I won't get this error. Otherwise, well, what does this mean? If letter is not in counts, then I should add it, and I can do that by setting it to 1, right? Because this is the first time I'm seeing this letter, so that means that its count should be 1. And I won't get an error here because I'm not trying to access some key that doesn't yet exist in my dictionary. And so with this change, we'll see that we appear to be getting some pretty reasonable results. Our E, for example, has, it looks like, maybe the most occurrences, which is probably correct because E is very common in English. And we might notice that, for example, the letter Z doesn't appear to be in here, right? And that's because we never see any Z's. And so another way that you could approach this problem, which is also a great way to do it, is to first, when we initialize this counts dictionary, we could initialize every letter to have a count of 0, right? So if we say something like, for letter in, remember that string.ascii lowercase is a string of all the alphabet characters. If for every letter I set counts at letter to what? 0, now I have a dictionary. Maybe actually let's print this out. Print counts. Now I will start off with a dictionary that maps every letter to the number 0. So I'm just going to run this and we'll see it. So after I run this for loop, I have a dictionary where A is mapped to 0, B is mapped to 0, etc. And then I can actually get rid of this if-else statement inside the for loop over the text, right? Because there will be no issue with the key letter not existing. And so I can actually just go ahead and get rid of this. I'm going to remove my printing of counts, and then we'll run this. And maybe we'll just check a random letter, like I has, in our new solution, I has 323, and in our original solution up here, I also had 323, and so I think that's good evidence for us that both of these solutions are correct. And so that is just 2 ideas for how to solve this activity. I hope that was helpful.